Hey guys, welcome to the Python programming tutorial for beginners by Uplatz. So we are starting with the advanced concepts in Python programming. So the basics are covered and we are starting with the advanced topics in Python. So we will start with a very popular module in Python that is known as the NumPy or NumPy module. Okay, so NumPy module is a short form for the Numerical Python. So NumPy stands for Numerical Python. Okay, so it's a very popular and a very common and a very elementary module you must learn if you want to perform the scientific operations using Python. Okay, so why is it so important? What can be done using NumPy? Where is the NumPy module used? For what purpose? Okay, for what operations? What's the importance of learning NumPy? Okay, so we will cover everything starting from the basics of NumPy to a very advanced level of programs using NumPy. So we will cover every aspect of NumPy in this series of lectures. All right, so let's begin by seeing the introduction to NumPy. Okay, so as you know, NumPy is a Python library used for working with arrays. You have worked with many basic data types in Python, right? We have used the data types like integer, float, strings, lists, dictionaries, sets, tuples. Okay, so we have seen all these basic types of data in Python, but the NumPy module is a very common and a very important Python library for working with arrays. So arrays is a collection of elements. Arrays is a collection of elements of same data type. Like lists, we have seen lists, right? Lists also is a collection of elements of different data types, but arrays is a collection of elements of same type. The values of an array should be of same type. There should not be any mix of data types in NumPy. Okay, so you can see the definition there. NumPy is a library consisting of multi-dimensional array objects and collection of functions for processing those arrays. Using NumPy, mathematical and logical operations can be performed. So as you know, there is a lot of things to do using arrays. Once we start with scientific and complicated projects using arrays, there's a lot of things to do using arrays. So NumPy, the module NumPy, provides every aspect what can be done using arrays. Okay, so it starts with how to create an array using NumPy, how to create it, what are the functions supported by the NumPy, what operations can be performed using NumPy on those arrays. Okay, you need very sophisticated functionalities to perform the scientific and mathematical operations using arrays. So NumPy is the module which provides all those functionalities and performance aspects for the arrays. All right, so the NumPy has functions for working in domain of linear algebra, Fourier transformation, and matrices. So the linear algebra, which is very important for scientific calculations, Fourier transformations, and matrices, there is a lot of things to do using matrix, right? So this NumPy module provides the the functions to perform these operations. NumPy was created in 2005. It is an open source project and you can use it freely. So when you install the Python, the NumPy will automatically come along with it. So you don't have to install anything else to start using NumPy. I will show you how to use NumPy. It's very easy. Once we are doing the Python programs using the idle. After a few lectures, I will start using another platform for executing Python programs that is known as Jupyter Notebook. So you don't have to install anything new to work with NumPy. So the NumPy comes along with the Python. You can just like that start working with NumPys. Okay. And what are the operations using NumPy? Mathematical and logical and scientific operations on arrays, Fourier transformations and routines for array manipulation, operations related to linear algebra. So once we start with the practical session, you will understand how these things are done. Okay. I will show you each and every function that is supported by NumPy, the basics of that, the examples of that, and we will also do some very important and needed programs on NumPy. Okay. So why to use NumPy? What's the importance of NumPy? You must understand that in NumPy, in Python we have lists that serve the purpose of arrays, but they are quite slow. So the lists as compared to NumPy are quite slow. I will also show you the examples of how to measure the speed between the lists and the NumPy. So you will see in the output, the NumPy arrays are much faster than lists, right? So lists are slow, whereas NumPy are fast. NumPy provides an array object that is up to many times faster than the traditional Python lists. So NumPy is very faster compared to that of list. What array you create using NumPy is called an ndarray. ndarray, that is known as n-dimensional array. It provides a lot of supporting functions that make working with ndarray very easy. So even a very small array that is created using NumPy is called an ndarray, that is n-dimensional arrays. And there are so many functions that make working with ndarray very easy. You can easily work with ndarray objects using the NumPy module. Arrays are very frequently used in data science, machine learning, artificial intelligence, where speed and resources are very important. Arrays are very important aspect or components of scientific programming like machine learning, artificial intelligence, data science, and there is something needed to support the functionalities of arrays. That's why we use the NumPy module, which has everything that supports the functionalities of arrays, right? So that is why NumPy is very important, and it is faster than lists. NumPy arrays are stored at one continuous place in memory, unlike lists. So processes can access and manipulate them very efficiently. So the NumPy arrays, right, the elements of the arrays are stored one after the other in the computer memory, which makes it very easy to access and manipulate. It is not scattered. The elements are not scattered along with the memory. They are stored one after the other. We will see that how they are stored one after the other using some functions. Okay, we will see the memory address of each element in the array. This is the main reason that the NumPy is faster than list. Since the elements sit next to each other, NumPy is much faster than the lists. Okay, and it works well with all the CPU versions. The NumPy module is optimized to work well with all the versions of the CPU, right? NumPy is written partially in Python, okay? But most of the parts that require faster computation are written in C, C++. So the NumPy, which language is used to write NumPy? Most of it is written using Python. But as you know, Python is an interpreted language, which is quite slower than the compiled languages like C and C++. The modules, the submodules inside the NumPy modules, which require fast computation, are coded using C and C++. Okay. So these are the things for the NumPy, the introduction of NumPy. Then we will see the different facts about the NumPy module. So as I told you, NumPy don't need any extra installation. It comes freely along with the Python idle or any platform where you are using for the execution of Python programs. We will see how to just import the NumPy module. So to import any module, you have already seen, right, how to import the math module. You have to use the import statement followed by the module name, correct? So that is how to import the NumPy module also. Just write import NumPy in your program and you are using the functionalities of NumPy, correct? So after that, you can create arrays. You can see the attributes of array in the slide. What are the array attributes? The shape, the n dimension, item size, NumPy, okay? The array creation functions like empty, zeros and ones, these are very useful. So what is a shape? Shape is how many rows and how many columns. If it's a 2-dimension array, how many rows are there and how many columns are there? That is known as shape. It can be 3, 2, which means 3 rows and 2 columns. It can be 5, 8, which means 5 rows and 8 columns. Okay, so that is known as shape. And what is n dimension? It tells the dimension, the number of dimensions the array has. The array can be 1 dimension, in which the n dimension will return 1. The array can be 2 dimension, in which case the n dimension will return 2. It can be a 3 dimension. All right. So we will see how to check the dimension of an array using the n dimension. Okay. Then item size. What is an item size? As I told you, array consists of items, right? So what is the number of bytes that each element is using in the memory? It is known as item size. So there are many data types which hold a particular amount of memory in the computer. Few items can hold 2 bytes, few items can hold 4 bytes, few items can hold 8 bytes, then 16 bytes, 32 bytes, 64 bytes. Okay, you have to select the data type for the array elements. I will show you how to select the data type for the array elements, and you can check the item size of each element. So the item size is the number of bytes each element in the array holds. Okay, then what are the array creation functions? You can see we have empty function, we have zeros function, we have ones function. Empty function will create an uninitialized array, that is known as empty function. So when you are creating an array using empty function, you are creating an array with uninitialized locations. The locations are not initialized, they are initialized to some random value so that you can change them later. Okay, so we will see how to use the empty function to create an array. This array will hold some uninitialized values. Okay, then zeros, you can also create an array using zeros. All the locations will be filled with 0. you can have a array, one dimension array. If that has 10 elements, if you use the zeros function, then all those 10 elements will be 0 at the beginning. If an array is a 2-dimension array with 3 rows and 2 columns, then you can initialize all the locations with zeros using the zeros function. Similarly, we have ones function, which will create an array with all the locations having 1, the value 1 in it. Okay, so that is known as ones function. The entire array will have the value 1. All the locations will have the value 1 in it. Okay, so that is known as ones function. Then these are the array attributes. So when we see the item size, so what are the different types of item size we can have? We can have a boolean, okay, as true or false. We can have an integer. We can have integer c, okay. We can have integer p. We can have integer 8, which holds 8 bytes. We can have integer 16, which will hold 16 bytes. We can have integer 32. We can have unint 8, okay, unsigned int 8. We can have unsigned integer 16, which holds 16 bytes. We can hold we can use unsigned integer 32, okay. We can use float. We can use float 16. We can use float 32. We can use float 64. We can also use complex. We can use complex 64. We can use complex 128, okay. So all these are the data types which will have some particular item size, okay. Then a data type object describes interpretation of a fixed block of memory corresponding to an array depending on the following aspects: the type of data, the size of data, byte order, okay. The byte order can be little endian or big endian, which which is not of concern right now, okay. And NumPy supports much greater variety of numerical types than Python does. So what I told you, the data types we can use in NumPy, it's much larger than what the Python supports, okay. And I told you the boolean, int p, int 32, int 64, all these are the data types supported by the NumPy. And few times the NumPy is also known as an alternative for the Matplotlib, okay, because it acts like a Matplotlib. The functionalities the NumPy supports are similar to the Matplotlib, okay. The MATLAB, what you use for the MATLAB is mainly used for the mathematical and scientific applications. So NumPy almost does the same thing as the MATLAB, okay. So these are the things you must know about NumPy. We will start with very basics of NumPy in the next lecture of how to create an array. Along with that, we will cover some advanced and some very important programs on NumPy. All right. So I will come up with the next lecture. Okay. Thank you. So when we see the item size, so what are the different types of item size we can have? We can have a boolean, okay, as true or false. We can have an integer. We can have integer c, okay. We can have integer p. We can have integer 8, which holds 8 bytes. We can have integer 16, which will hold 16 bytes. We can have integer 32. We can have unint 8, okay, unsigned int 8. We can have unsigned integer 16, which holds 16 bytes. We can hold we can use unsigned integer 32, okay. We can use float. we can use float 16, we can use float 32, we can use float 64, we can also use complex, we can use complex 64, we can use complex 128. Okay, so all these are the data types which will have some particular item size. Okay, then a data type object describes interpretation of a fixed block of memory corresponding to an array depending on the following aspects: the type of data, the size of data, byte order. Okay, the byte order can be little endian or big endian, which which is not of concern right now. Okay, and NumPy supports much greater variety of numerical types than Python does. So what I told you, the data types we can use in NumPy, it's much larger than what the Python supports. Okay, and I told you the Boolean, int p, int32, int64, all these are the data types supported by the NumPy. And few times the NumPy is also known as an alternative for the Matplotlib. Okay, because it acts like a Matplotlib. The functionalities the NumPy supports are similar to the Matplotlib. Okay, the MATLAB, what you use for the MATLAB is mainly used for the mathematical and scientific applications. So NumPy almost does the same thing as the MATLAB. Okay, so these are the things you must know about NumPy. We will start with very basics of NumPy in the next lecture of how to create an array. Along with that, we will cover some advanced and some very important programs on NumPy. All right, so I will come up with the next lecture. Okay, thank you.